challenges, come see me and we can talk about it. So I have a few goals that I'd like to accomplish in this talk. One is to basically teach you the Elasticsearch terms and concepts and how you can use Elasticsearch within Rails, give you some examples of some queries and filters and what you can do with Elasticsearch. And then finally, give you some tools on how you can manage and actually tune Elasticsearch for your environment. So what is Elasticsearch? It's an open source distributed RESTful search engine that's built on top of Apache Lucene. And it provides clustering failover and auto discovery. And it's a schemaless document store that deals in JSON documents. By show of hands, how many people will do some sort of full text searching today? Awesome. And how many are doing that in the database? Oh, good, not too many. And how many are using Elasticsearch already? Awesome. So I'll give you a little background on how Spiceworks came about to actually use Elasticsearch. We have a big focus on helping our users actually do product research. So we cater to a lot of IT professionals in small and medium-sized business. And we want to give them tools that they can actually go out, learn about products, do some research on that, and figure out the data that they need in order to do a purchase. And along those lines, we want to be able to have autocomplete, so as they're searching for products, we can show the suggestions. And then if you're actually going to look at a specific product group, we wanted the ability to filter those and narrow those down so they can actually say, well, if I'm looking at networking equipment, I may only care about a particular manufacturer, particular price range, and so forth. And so we wanted to use Elasticsearch for that as well. And then as time went on and we actually got more familiar with Elasticsearch, we wanted to replace some of the inefficient searches that we had that we did in the database. We used Postgres and we used the full text search engine there. That is a reverse index as well, but it's obviously not as efficient as Elasticsearch. And then finally, our traffic has grown so much in the past couple of years that we're actually hitting the upper bounds of free site searches. So we actually want to bring that in-house, not only to reduce our costs for that, but to add additional features to the search. So I'll go over a few Elasticsearch terms that you're going to hear as you read about it. The primary thing is the Elasticsearch node. And what a node is, it's an instance of Elasticsearch which belongs to a cluster. You can have a single instance of a node that's all standalone, and you can have as many of these as you need in a cluster. The next piece is a shard, and the shard is the primary data partition within a node. And there are two types of shards. There are primaries and replica shards. And the primary shards, you actually specify index creation time, and keep this in mind because this is an important point, so when you're actually trying to tune Elasticsearch, this matters. And generally, a rule of thumb is that the more primary shards you have, the faster you can index documents. And if you're familiar with Lucene, a shard is equivalent to a Lucene index. And then you have replica shards, and these you can actually modify at runtime, and this helps with scaling out actual searches. And they're just copies of primary shards that are used to increase performance and failover. So we have more Elasticsearch terms. Who doesn't like reading the dictionary? So an index in Elasticsearch is a top-level data partition, and there can be many indices inside a cluster. And these are split across multiple shards. So when you find the index, you say how many primary shards you have, and it spans that across those indexes that may live on one or more nodes. And then you have a document type, which inside an index is that type. It's kind of analogous to a database table. So the index is, you can kind of think of that as a database. Document type is something along the lines of a database table. And then finally, you have a document ID, and that's a unique identifier for identifying that document within an index and document type. And these usually will specify, when we're working with Rails, tires will use your ID column for the document ID and the Elasticsearch index. But if you don't specify, Elasticsearch will actually auto-generate that. So I kind of want to show you how easy it is to get Elasticsearch up and running and actually start playing with it. So we're going to use the browser with that just to kind of show that. And I'm going to attempt to demo guys by doing this a lot. So I've downloaded the database Elasticsearch. We're just going to untar that. And then we'll go into that directory, and you just start it by doing Elasticsearch -f. And this is actually starting Elasticsearch, and it will be up now. So now if we go to the browser, we can actually go to the endpoint it exposes, and we can actually see that it's running, and it gives you like the version running, the node name, and front end line. So there's nothing in this right now, obviously because it's a fresh install, but there are endpoints where you can get data from Elasticsearch. So in this case, we're going to ask for the stats for the current instance that's running. You're going to see there's nothing happening in this because it's a fresh install.
Man plus.
So let's load a bit of data. So I went through and just created some really simple JSON documents based upon the talk. So I don't know how well you can see this from here, but it basically just has a title and a speaker. And so we can load this into Elasticsearch using curl.
Can you make it bigger?
Yeah, command plus.
So we just specify the index name that we want. We're going to call this RailsConf. We'll call this a talk, and then we'll just give it the JSON file. And so you can see that it came back. Since there wasn't an ID column in there, we didn't specify one. It generated one, which is basically a hash. And I'll load the second one. Same thing. So now if we go back to the browser, if you look at the stats, we can see that we actually have a couple of documents. So we've got two documents that we loaded. Gives you some statistics around the size and also around how long it took to index and so forth. So now we can actually search this. And Elasticsearch exposes the search point here. We'll just say, let's look for cloud. And we can see one of these documents actually refers to cloud. And we'll zoom in so you can see that I'm not lying to you. Now that's all fun and dandy, but let's actually load in a little bit more data so this is more useful. So I've gone through, I extracted out all the talks, and now let's see how many talks were about the cloud this year. So we found 5 results, and here are all the talks that were on the cloud. So that goes to show how quickly you can get up and running, get indexed documents, and actually play around with Elasticsearch. So now let's talk about how you use this within inside a Rails app. And so a popular gem is actually Tire. It's been around for a couple of years now, and it's actually progressed quite a bit in the last year to 6 months. And it's really easy to get up and running. So we installed Elasticsearch already, but if you are adding this to a new project, you're just basically going to edit your gem file, add Tire, do a bundle install, and then go into the ActiveRecord models that you actually want to index and include a couple modules. And these are Tire model search and Tire model callbacks, and we'll get into what those do here in a second. And then you can import your data into Elasticsearch, either using a rake command, or if you go to the console, you can actually import it. So I'm actually going to go over, and we have a forum, and I actually have a copy of some test data in there. So I'm going to index topics. So I already went in for the sake of time and added those modules to this topic. And I'm just going to call topic import. And this is going to go out and batch load all those topics inside Elasticsearch. And we have about 9,000 documents. It should be done here in a second. So now that's all done. So let's go back to the browser and take a look at the stats around topics. So we can see here that our store is 2.1 megabytes, and that we loaded 9,606 documents. And again, we can do a quick search on that just to validate that we have our data in there. And we'll just search for Ruby. And you can see we found a couple topics that actually discuss Ruby. So let's talk about the modules that you just included. The first one is Tire model search, and this basically exposes the query DSL that Tire uses for interacting with Elasticsearch. It also allows you to specify your index settings, so you can define how many shards there are and how many replicas. And then it also defines mapping, so you can actually define the data types within the index and some additional settings. And we'll talk about mappings here in more detail
And then you have tire model callbacks, and these use the ActiveRecord callbacks on cut operations. Thus, we have hipster cow here for that. So these are going to be the after save and after destroy methods. So there are some caveats with callbacks. If you saw Ernie's talk, you know about some that are in general. But these are more along the lines of performance as you're indexing and querying. So all the index updates, if you use the callback module, happen in the current thread. So as you update a model, it's actually going off doing an HTTP request to Elasticsearch. So you want to keep in mind, depending upon the volume of documents you're indexing and your response time sensitivity, you probably want to implement a worker queue system to actually handle indexing and updating. So something like REST-queue, Sidekick, or your favorite work queue. So some of Tire's default behaviors. So if you just include those two modules in import, it's going to index all the model attributes except for ID. It uses the ID for the document ID in Elasticsearch, like I said earlier. It uses Rails-like conventions for naming the index and the document type. So for the index, it's equivalent to the database table name. And then for the document type, it's basically doing the model name _. So in the example here, for our topic class, it's going to be stored in the index topics with the document type topic. And you can actually look at a specific document. So like we did a search, there's an endpoint for actually querying an individual document. So in this case, we'd do topics, topic, and the ID, and it would pull back that document. So more Elasticsearch terms. So we talked about mappings. You have an endpoint for actually looking at those as well. So if you didn't define a mapping and you kind of want to see what Elasticsearch guessed based upon the data that was importing, you can just go to that URL and see what it is. But in this case, I have an example for the topics that we just loaded. Within your ActiveRecord model, you can go in, define the index name here, and I don't know how well you guys can see this. So let me see if I can zoom in a bit. And then you're going to tell which fields that you want to index. And you can see here that we're explicitly giving the types. Elasticsearch is pretty good about guessing the types, but it never hurts to actually go through and say what it is. Excuse me. Now you can also define analyzers and boost settings. I'm going to talk about analyzers on the next slide, but a boost setting basically says that if Elasticsearch matches on that field with the given term, that it's going to increase the score by some percentage. And so that's a way you can actually give favoritism to a given field. So in this case, if we match on subject, that probably means that the topic is more relevant than if you match on the topic text. So the analyzer determines how Elasticsearch indexes a given field, and they are composed of a tokenizer and 0 or more filters. So what does that mean? So if we have a given text here, and I'll give points to anyone who recognizes this, but say we have, I hate the wetlands. They're stupid and wet, and there are bugs everywhere. And I think I maced a crane, Michael. What Elasticsearch is going to do with that is the default tokenizer is going to actually rip out stop words. So those are things like the, and so forth. And it's going to rip out all punctuation, and then going to do a lowercase everything. And so the tokenizer is responsible for basically breaking apart the text that you're indexing. And then the filter is doing operations on that text. So in this case, tokenizer removed the stop words. The filter converted it all to lowercase. And this is all customizable. You can actually specify per field how you want to process that. So what if we want to do something interesting? So you're like, great, let's show me something that's cool. So we'll do a quick autocomplete demo. So in our example here, in topic, we're going to do an autocomplete on search. So all we need to do is define a method, use the tire DSL. We're going to say we're going to search on the subject for a given term, and that's all there is to it. And then our topic controller, we just expose an endpoint that we can call. In this case, we're just calling it autocomplete, and it's just going to pass the term to the topic subject matches and then render those results. And then, of course, we have a simple HTML document that has a field for doing the autocomplete, and we're using jQuery's autocomplete plugin for hooking that all up. And in this case, I'm using JSON-P since I'm running this all locally on my box. So if we go back over here, I have this form up. I can search for Spiceworks. And here are a bunch of topics that have Spiceworks. We actually have mentions of Rails. Neat HTML5 feature, Ruby without Rails. And here's one of my favorites. If you search for Java, you have, where is that? Of course, it's not going to show up now. There's a great topic that said, Java use is declining. Is it because of Mac malware? And I was like, yeah, I think that's probably it. So you're probably thinking, oh, great, that's something I can do pretty easily with databases now today. So, thanks, but no thanks. So let's go in and make this a little more interesting. So if we go back into our subject matches, I've actually done another example here where we're going to do a little bit more complex query. So in this case, we're going to say we're going to still match on the subject, but we're also going to restrict it to a given form. So we're saying it has to belong into this form. And then we also want to restrict it to say that the topic must have been created in the month of February. And then the other interesting part is we're going to ask Elasticsearch to highlight the terms that it matches in the subject. So if we go back here, save that, go back to our example, search on Spiceworks again, wait for the class reloading, and now you can see we actually have highlighting pretty easily. So very powerful to get up and running, so you didn't take much time, and you have autocomplete with highlighting. You can configure how it does highlighting. It's basically inserting emphasis tags around these now, but you can actually override and say you want a particular tag around that. So here are a couple other query examples. Paging is really easy, uses kind of the standard pieces that you'd expect. When you do a search, you can pass in the page number and how many results you want per page. And then you also have filters or facets. And to kind of clarify this, I'm going to go to a test harness that I use. And I actually need to start a different Elasticsearch instance. So we're going to bring up one where I've loaded a bunch of product catalog data. And then I'm going to search for a Bluetooth mouse. And you can see that it's still pretty quick. That was from a cold restart. We have, I think, around 800,000 products in this index. And you can see I have mad UI design skills here. But this is my test harness that as I'm going through, I can actually see that I'm getting results that I want and just validate things that are working. But getting back to the point, what a facet and filter, what those things are, on the left-hand side, we have things broken out by vendor, manufacturer, price range, and ratings. And so these are all considered facets. So a facet is you're basically asking for the possible values that exist at a given field. So on our catalog, we actually have a vendor field. We also have a manufacturer. And you can see here by default, it returns the counts that for the given search match that. So we can see we have 816 products from this SCW vendor. We can look at the different manufacturers and see, oh, there are 58 results from Logitech. So if we click on one of these, this is considered a filter. You're basically saying, given the Bluetooth mouse query, I want to restrict those results to only those things that match the filter of manufacturer Logitech. And you can combine these as many levels as you want. So if you want to, again, restrict it by vendor, say I want to only see PC connections, Logitech mice, you can do that as well. So given that example, hopefully this clarifies this a little more. The tire DSL allows you to specify the filter that you're going to apply. So in this case, we're saying it's a term filter against the last post author field. So we're saying only show me those things that match the term and that were written by Spiceworks. And then you can specify the facets that you want to return so you can display those results by giving it a name and then telling it that you're doing a term facet on the last post author. So there are a couple other options excuse me, for doing range filters. And I'll show you an example of that here in a second. So we kind of had something similar to this, but just kind of showing you some other flavors of Boolean searches. You can combine all these different pieces to say, okay, this must match this given term, it should match this category. What that means is if it does end up matching that category, the score for that result is going to be higher and show up higher in the list. And then you can also do things like it must not be in an active post. And you can do sorting as well. This is very similar to the ActiveRecord pieces. You can specify the field that you want to sort on in ascending or descending. So Tire out of the box supports most of the common filters that or queries that you would use, but there are many additional queries that Elasticsearch supports that Tire doesn't natively handle in its DSL. So if you run into one of those cases where you're trying to do a more complex query than what you can do in the Tire DSL, you can still use Tire to do that search, but you're basically going to pass in a hash of that query. So Elasticsearch deals with JSON documents both for its query interface and actually its document store. So what this is going to do is it's just going to convert the hash that you passed in into a JSON document, pass that to the query point on Elasticsearch. So the thing to keep in mind if you do have a multi-node cluster and you're using Tire is that it's going to need some type of load balancer. By default, Tire just queries a single Elasticsearch node. And there's been some debate with the Tire author on why he doesn't expose the option to specify multiple URLs. And his point is basically that's a well-known problem. It's been solved by stuff like HA proxy, by general load balancers. Why include that in Tire and make it more complex? And then the author of Elasticsearch has come up with another solution that you can basically create another instance of Elasticsearch and set that it's only a client and that it doesn't store data. And what that means is that that node is just basically going to proxy queries across the cluster. So those are two options that you can deal with. We actually use a load balancer in our environment across a two-machine cluster. So how can you actually monitor and make certain that things are working and determine if, when you're tuning, if you're making a difference? Well, there are a couple plugins that you can add to Elasticsearch that give you a lot of details. The two ones that I'm familiar with that are, I think, some of the most popular ones are Paramedic, and this was written by a guy on the JBoss team at Red Hat, and then Big Desk, which is written by the Tire author. So let's show you what these look like. I've installed these plugins already, but they expose it through similar URL. You have underscore plugin, and then you give the plugin name. So this is Big Desk, and it shows our cluster name. We have a Blue family cluster, and we have a node, Michael. And so you can select a node and kind of see the basic stats around that. It'll give you JVM stats, and it'll give you internal Elasticsearch thread pool stats, OS stats, and so forth. So this is very interesting as you're going through. You can look at your index behavior, how many requests you're getting, how many documents you're indexing, and as well as file system behavior. So this will give you a good insight on the health of your cluster. And you can also get a visualization of your cluster. Right now I'm only running a single node, and so this is showing the Blue family node and all the shards inside of it. And I don't know how visible this is, but you can see we have these tiny little dots in here. These are the topic indexes that I created earlier, and they're relatively small. They're 475K or so. And then we have our catalog, and these are much larger. These are around 140 megs. So it kind of gives you a nice visual, how big are your indexes and shards. So likewise, we have Paramedic. And this shows you a lot of the same data. It's just a different format. It'll show you the status of your cluster, and I'm going to talk about why this one is yellow. It'll give you some basic OS stats, JVM stats here. And then it'll show your indices, and you can actually look at details. So these are the actual shards inside the catalog that we're using. So I specified 6 shards when I created this index, and you can see how well it distributed the documents across those by looking at the size. And so we also have the topics index, and you notice that we have a bunch of yellow nodes here. Now, why is that? So by default, it creates 5 shards and 1 replica copy. But if you only have 1 node running, the replicas don't make any sense to actually allocate on that machine because the purpose of those are for failover. So if that machine dies, that you have another copy of the data. And for distributing the actual index or actual queries. But on a single machine, you already have copies of that data, so why would you have another copy on the same machine? So it just doesn't make sense. So replicas won't be allocated on a single node. But what I want to show you is kind of a really cool feature of how Elasticsearch is very dynamic and how you can add additional machines and it's going to automatic rebalance. So I'm going to bring up a second instance, and let's go back and watch this. There we go. So now we have a second node named Tobias. And what you're going to notice is that it's split the shards across two machines now, or two instances. So we have Michael that has the 1, 2, and 5, and we have Tobias that has 0, 3, and 4. So it's automatically distributed that data and rebalanced it for you. So this is awesome because as your needs grow, you can just add additional machines. Elasticsearch handles all the rebalancing for you. And now you can see that we're actually at a green state because it was actually able to allocate the, excuse me, the replicas. And in this case, not ideal. Tobias has all the replicas and Michael has all the primary. So let's go through and actually add some replicas to our cataloged index. So you can do this through the curl command as well. It exposes underscore settings hook. We're just going to give it actually a number of replicas 1, and we'll go back and look to see what happens now. So you can see under the catalog index, Tobias now has a total of 6 nodes, and so 3 of those are replicas and 3 of those are primary, and it's distributed those across those multiple machines. So this is, I think, a very awesome thing, is now all of a sudden you can balance those requests against 2 nodes, and you didn't have to do anything except bring up another instance. So what these UIs are doing, they're basically just hooking into existing endpoints that Elasticsearch exposes. So you can look at a lot of this data in the browser by default. So here are 3 examples. You can look at the cluster state, cluster settings, and index statistics as well. And I want to touch a little bit on how you can scale Elasticsearch. There are whole talks just based upon this, so I'm not going to go into a lot of detail, but I want to basically make you aware of a couple items. So when you define your index, you're basically going to be restricting how many nodes that you can actually have inside your Elasticsearch cluster. And there's an easy way to figure this out. It's simply the number of shards that you define, primary shards, plus the number of replicas times the number of shards you have. So for the default index, when you create that with Elasticsearch, it defaults to 5 shards and 1 replica, which means you can have up to 10 nodes that will be utilized. So you can add more nodes, but it's not going to do anything with those nodes. They're just going to be, there's not going to be any shards on them. So the thing to keep in mind is when you specify the primary shards, those cannot be changed. After you create the index, it allocates those, and you can't go in later and increase the number of those. So what you have to do in that case, if it turns out that you have an increasing load of documents that you need to index, you're going to have to create a new index, copy those things over into the new index, and then create an index alias to redirect to the new index that you created. So keep those things in mind. You can always increase the number of replicas, and so the most common use case is you're going to actually be doing more queries than more indexing. And so those are easy to increase after the fact and scale your node even more. And then another thing that I just recently learned about, and I don't have a use for this yet, is you can actually give Elasticsearch hints on where it should go to search for data. And so this is called index and query routing. And by default, when you actually issue a request to Elasticsearch, it's going to all the nodes, asking for their results and then aggregating it for you. With this, you can actually short circuit that and say, I know that this document's on this particular node. You give it a route, it will go there and do that. Again, that's going to be for somebody who's doing super performance stuff, and you probably won't have a need for that initially. So some bonus information. Elasticsearch 0.90 was just released this past Monday. It's now using Lucene 4, so you get all the benefits of that. He's done a lot of work around the document balancing. So before you could actually notice that some shards would actually be hotter than the others. Now with 9.0, it actually balances it a lot better. And then if you're interested, if you don't stay out too late partying tonight, you can get up tomorrow and at 9 a.m. they're doing a webinar on the new features of Elasticsearch. And you can contact me here if you have additional questions. Well, thank you for your time.